Welcome. Welcome. I'm going to record this so those who couldn't participate today can listen. So again, thank you so much, Jay. Taking time to explain something. I would say, as rationalists, being curious about things are one of our main, things we kind of drive us, most of us. So and this is a very important topic, and Jay is extremely well qualified to talk about it. He is the senior architect at Microsoft and on cloud architecture, and he has an exceptionally, brilliant career, university rank holder, and has worked in many firms, including Capital One, and now in Microsoft. And he's going to walk us through what this cloud is about. I'm personally have a very very basic idea. I mean, just as a user, but it'll be interesting to know. So I'll put my speaker and camera on mute, so that Jay can, and I'll highlight Jay so that way it will be
Okay,
all
thanks,
right. Welcome.
Khalil. Thanks for that intro. So again, my name is Jay Kumar. I work for Microsoft as a cloud solution architect. What I usually do is my role is more like an advisory role. What I work with my customers to help them out with building infrastructure, applications, and deployment of all that stuff. So basically, I work with a variety of customers and help them out with migration from their on-premises infrastructure to Azure, which is my Microsoft's cloud's name. Basically, I'm not going to talk a lot about Microsoft Cloud today, but I am trying to provide you guys with a very high level overview of what cloud means. And it is again, it's a little bit of a difficult for way to present to people who are not very used to cloud, because there is a bunch of stuff. So I'm trying to, I tried my best to put that in like a more like from end to end, talking about a little bit around what an application is and how you connect to an application sitting at your home. And let's say, for example, if you are trying to connect to a financial application, Capital One, for example, like their website, how does that work? And how does that work on premises? Like if they have all their applications running from on premises, and how does that work if it is moved into cloud? So I'm trying to explain in that way, and also maybe explaining some of the basic concepts around how internet works and things like that. So with that, let me just get started, and I have some slides here which I will share now, and we'll go from there. um, yeah, so can you see my screen share now? Okay.
Yeah.
All right. Um, so first of all, what is cloud computing? So cloud computing, in very simple terms, is a delivery of computing and computing services, including servers, storage, databases, networking, all such things from the internet. So this allows you to for faster innovation and flexible resources and economies of scale. So when we say economies of scale, it means that when you are doing all by yourselves, you have limitations in moving up and down, or like based on demand and stuff like that. So when you have a multi-tenant environment, just like an apartment complex, you can move in and move out, and then use resources at scale. Depending on the builder, you can actually use those things. That's kind of the rationale behind economies of scale. And so you typically pay only for the cloud services that you use, helping you to lower your operating costs and run your infrastructure more efficiently and scale as business needs change. So if you're trying to do your own on-premises environment, forecasting and building new infrastructure for new business opportunities, things like that will take a lot of time. And then obviously the life cycle or the times required to do all that will be really a downside for your business. So that's why people use the flexibility of the cloud for all these things. So that's kind of the basic startup, and then we will talk about a little bit around how this evolved. So if you guys already know around the history of computing, there is a big evolution happened from early days. We had mainframe applications, right? So mainframes are big beefy machines. They are like monolithic. They have just they sit in on a on-premises environment like a data center, and only people who used to interact with are the business people working for the companies. You and me, like people are not, the customers are not interacting with those. So they have terminals in their desks, on their desks, and they actually query something, like they actually write stuff in a very cryptic language, and then they query for certain things, like when you call them up for something and they will just query that, do some calculations, then it's going to be like very much like the old way of doing things. That's kind of the mainframe approach. It was actually replacing some of those computing that you used to do by hand, but machines took over that part. That's the back end of everything. We call it like the back office computing. So then later on, we had multiple distributed servers. All right. So what happened now is like maintaining and buying mainframes is a very big business, right? It is very costly. It needs a lot of money. Not everybody can afford it, and so we started off with multiple distributed servers, which are very small machines, and we tried to do desktop applications, and the personal computing came up, right? For example, the PC revolution happened, and we had personal desktops, and we people were trying to interact with the backend systems. So we have a front end system like a PC or something, and then you want to talk to somebody who's sitting at the back. So we started having multiple distributed systems. So we have a distributed computing architecture where we actually took away all this monolithic approach and then sliced and diced into different small components. And then so we had this multiple distributed servers, such as Linux machines, Unix machines, and we call it like you might have heard about Sun, Solaris, or like Unix, HP UX, those kind of machines were at that time. So basically, we were transitioning away from the mainframe, and we're trying to do all these things. And eventually, we had high intensity server farms. So basically, what happened is like companies started having their own infrastructure with all these distributed computing. They started building their own premises environment, which is like a data center, and they host all these machines. They build this framework, and they will provide these services to actual end users, not like the actual people sitting in the offices, right? So then the internet evolved, and then everything is served over the browser. So there are two different ways to interact with backend systems. We could use a something called a fat client. Fat client is something like you are running a client application on your machine. It is like very proprietary. You use that application solely for that purpose. For example, if you may be using a trading application for brokerage houses, you may download that and you use that for that purpose only. It will connect to that backend system, and you'll be doing all those excuse me, all those trading systems. But so browser is called a thin client. It is a universal client for many systems, and then we have a protocol that allows you to deliver content into this browser. So that's how browser-based applications came. So it is a very flexible, and so basically, if the reason for not using fat clients, because when you are trying to use fat clients, it makes a dependency on the client itself, right? Everybody has to download that. They should be able to know how that works, and then it is going to be a lot of trouble for common people to do that, and it is unnecessary. So we had the internet revolution, and everything was delivered over the website or the web server or the browser. So that's how the internet applications came. So then again, so people were delivering their solutions over internet. And if you look at like maybe if I go back to my tenure in Capital One, when I was there around 15 years back, if we were to deliver some applications to the people, what we will do is a forecasting process, right? At the beginning of the year or the business year, we will say, okay, there are so many systems we need to build. We need these many machines. So there is an inventory taking process, and then people will work with there is a team called IT management, which will work with the several application teams, and then we will take stock of how much is needed, and then we start purchasing those things, and then you're connecting all those things in their facility, wiring up all of them, racking them, and then connecting them and everything. So it's a lot of time. And we used to wait for 3 months to get a server. So at that time, it used to be a physical host. Basically, there was no virtualization at the time. So what we do is, like, for every application, a single machine is required, and that we will put the application on that machine. And then eventually we had virtualizations, which means that we have a physical hardware. On the top of that, we have multiple virtual machines, which are like not really physical machines, but we carve out a small machine on top of that. And so that will allow you to provide these type of flexible environment. So basically your forecasting actually is is much more flexible, right? You forecast how much capacity you need in terms of your businesses that is coming up, not for the specific application. You are not buying for a single application. You are buying for your business goals actually, and then everybody gets a piece of that by just getting a virtual machine on top of that. So that's how the virtualization and the data center came up in the, I think this is around 10 or 15 years back. And then the cloud came up, which is more like moving everything into somebody's as a service provider. So hopefully, any questions so far? Is this making sense? So feel free to stop and ask questions if you have anything. All right. Okay.
Hey, yeah, I have I'm coming from a software background, so like most of these terms are familiar to me. But maybe like if you provide some examples of like when you say about a virtual machine, like if you maybe the beginners might not know like what a virtual machine is. So maybe
Yeah, I will. That's actually, I have a series of slides that will talk about virtual machines as well. So
yeah.
I'll just stop it here because for the big picture, that is good enough. I think we will cover the details in the couple of slides, like going forward. Right. Okay.
That was a good overview. Yeah.
Okay. Sounds good. Right. So now let me see. I think people may not be exactly knowing how internet works. So I think I will also provide a very high level overview, and then we will go a little bit deeper into some of those concepts, and then see how what we are trying to replace here. So you see that a web server sitting at the back end. That is the when you so you are at the front end. If you look at the left bottom here, you see a computer, like a laptop sitting there. Somebody is trying to access an application on the internet, and it is making a lot of steps in the between, and then it finally ends up in a web server. Somebody is hosting it, and that could be a data center, which is on. Let's forget for the cloud scenario for now. Let's think that this is sitting in an on-premises data center, right? So before cloud, all these things were going into somebody's data center, hits some server sitting there, and then the server will provide the content back through the response. And the green line going towards the server is the path that it takes from your machine, and you get a response back. So in between, you have a modem, which, or maybe a router, whatever, and a modem is a modulator, demodulator that actually helps to send these pulses, or the electric pulses, from your Ethernet connection or wireless connection into the internet. The router actually routes it into several steps, and I will talk about domain name servers and then web servers and all that. So it actually goes through a series of steps, and finally it will know where to go, and it will come back to wherever it started. And it is not going in one piece. Actually, it is all cut, and because you cannot have that kind of connection between one server and the backend. So it is almost like cutting it into so many pieces and attaching labels and sequence numbers and all that stuff, and then you are just throwing it out into the internet, and it takes multiple paths actually, and it depends on the most efficient path. And the third packet may come up earlier at the website and at the web server, and then it will be a reordering done at that place, and then all these things happen in the flip of a second. It's kind of amazing to look at all these things. If you're really getting into this, it's really exciting to see how it works. So and so let's talk about the components sitting in between you and the backend systems, right? The first thing is DNS. It's called a domain name system, right? So you just type google.com in your browser. So how does your browser know where to go for Google? The Google is basically some IP address, which is like a physical IP address that is sitting somewhere. And so we need to find out what that google.com maps to. Like it has to provide a real address for that. It is just like I'm telling that I need to go to Khalil's home, and then somebody has to tell me what is the address of Khalil's home. So that's all. I'm just giving a symbolic name for. Otherwise, all the users have to remember all these 120.13.10 dot something like that, some kind of four tuple numbers that they have to like remember and type in for everything. That's not very feasible. So we just provide a symbolic name, and the first thing happens is it goes to something called a resolving name server. That is the first entry point. And so basically you have at the higher level you have .coms, .nets, and all sorts of things. So we need, so there is, this is like you're trying to find an address, and then you have authorities across different jurisdictions, right? So you have a city, you have a state, you have a country, things like that. So we need to know where it is actually finally going into. So first of all, it will find a TLD, which is something called I forgot the exact the full name for that. Some target level domain or something like that. So basically, the TLD name server finds out what is the root of what is the starting point for that domain. For example, if .com has a TLD and .net has another TLD, so it will first go there. Like, I need to know where google.com is. Like, it will tell you that what is the root name server for that. It will give you the next level of where to look up for the Google. And then the root name will point you to the authoritative name server. So everybody has, like, suppose I am hosting a web server. I should provide, I am buying a domain and I am actually hosting something. And I have designated an authoritative server for giving my addresses. So somebody is authoritative for providing my name is the final endpoint. And there from there, it is actually, it's a recursive process. It goes and turns around, and finally it finds out the addresses and gives back to you. So when you click here, when you try to put in google.com or something like that here, the first thing happens is the DNS lookup. So it will find out what is IP addresses it has to go. And even that traffic itself is taking in a packetized format. It is not a single connection. There are so many protocols happening here. Like the first protocol is DNS lookup protocol. And then eventually the data, all those things will happen. But first of all, it actually takes the level of DNS lookup. And then it finds out a domain name or an IP address for that and gets back to you. And that's the first step. And then what happens is the routing happens, right? So the way internet works is there are a bunch of autonomous systems, right? There are a bunch of routers, and like from your home, you are trying to reach somewhere. And then there are like independently controlled systems, like for example, Microsoft is one of them. Google is one of them. They have their own set of servers and domains and stuff like that. And there is an edge router on that. Like basically you sit at the edge, and somebody wanted to go there, will only provide it to the edge. And then the inside that, you don't really care. Like the routing happens within that. And so there are these interconnected pockets of routers, or like group of routers. So that's the authoritative autonomous systems. And all these, like if you see these networks here, the network one is an autonomous system and the other. So basically from your router, it will know if to get this computer, there is a routing table. So my computer says, if I have to go to Google, my next hop, or like the next address I need to go is somewhere here, and it could be here, and it will take that route.
Jay, can I ask something stupid?
Sure.
So if I type Google here and Google in India, it goes to the website shown is different. So how is that? I mean, is it location based? Which server it goes to?
There is a bunch of other things which I don't cover here, but there is load balancing, and there is also redundancy and all sorts of things. Like, if everybody is trying to go to a single server in Google, that's going to be crashing pretty soon, right? So there is also things like multi-region, like they may have the same. So that is part of the DNS resolution, right? DNS also can give multiple IP addresses. Like DNS probably may not be giving you the exact IP address all the time. So it can have, Google may have a series of servers that actually host the same thing. And so it will be doing a round robin, or like one at a time, like going all the way through. Like the first guy goes to one server, second guy goes to another server, all those stuff that can happen. And
So
there is
it
also
has a way to know, right? It has a way to know where the search is coming from,
yeah, so
where
it
I'm
doesn't.
typing it from.
So the search part is again the backend process. I don't want to go too deep into that.
Not the
If you,
search, but the actual website itself is different, right? When you say Google, if you go to Google in India, it is going to be, same
that
computer.
actually, because the DNS is providing a different domain, different location for that in India, because
Particular,
you are
right?
typing google.in in India, for example.
Oh,
So
is
the
that right?
IN is, so if you look at here, the TLD name server for IN is different,
Okay.
because it's a different country, right? So it is like I
Right.
told you, like .com, .net, .in, .jp, .au, all kinds of domain,
Okay.
the domains are there. So it will, that's one part of it. And then that's how it can go to different servers for the same URL.
Okay.
And the other thing is personalization. So even if you go to the same server, Google remembers who you are, and it does something called cookies, and then it will have some information around you, about you, and it will do some personalization on the data that is getting back to you. That is again application level. It is not. So there are a bunch of levels we talk about. The application level is where it is massaging all these things, but
I think
the
even so
yeah.
basically the person who is requesting, the server can know the location, a
Yes.
kind of approximate location of the user, right?
Yeah,
So
that
they
is
can
again,
personalize based on that.
that is called the IP based affinity. So what it does is, when you are trying from so again, that is actually much more relevant in cloud based business. The cloud actually can be deployed in so many regions. Like I can have my environment running in US, in UK, India, and all that. So depending on where the customer is coming, there is a global load balancing stuff. It will actually provide services from closer to you, because all these things are limited by the speed of light, because these are electrical pulses, and the max speed you can reach is the light speed. And if you are like the farther away, it will take more time. So so that's why we should be, so to your question, like it will also detect, there are some load balancing strategies which is called proximity based load balancing, which will allow you to like provide your server closer to you. Okay, so this is again the routing. It actually somehow fine. I don't want to go too deep into the. This is again, I want to give you enough details as well, and also not overwhelm. So I'm trying to give that balance. So basically, you have autonomous systems, and that hand over to the next autonomous system, and finally it will reach the destination. And that's how the internet works. So if you look at this diagram here, like there are like points of autonomous systems, and it will interconnect and all that, and it will just do all these kind of business by being there. So that's how the routing works. And now there is something called a protocol stack network. So when you are, so let's say you are connecting from this server to the another server, like this is your client and this is your server. So you have, there are several layers of connections, right? The physical connection is here only, which is very much like a electrical pulse of 0 and 1s that is going through the wire, which is very unintelligible for the application, right? It is the last piece of thing, but combined, all these things make sense. So we have put layers of knowledge on top of all these things, right? So at the top level, and there is also something called OSI, Open Systems Interconnect model, and this is a TCP/IP model, which is kind of a subset of that, which I'm trying to in terms of internet, we usually use this. So in the application, like let's say I'm trying to connect to capital1.com, and I am actually typing in my username and password and all that, and then I'm submitting it. So that is application data. So that is sitting here. So that is at that level, and it actually seems like your application is talking to the application on the Capital One side. but it's a virtual feeling. There is no real connection like that. It is called that's why it is called a virtual communication. So you feel that I am typing everything and it is connecting there and it is coming back, but it is not happening at that level. It is actually happening really here, but then we have padded all these things such that the whole thing goes in a format that is detectable at the other end, and you can assemble back and then give you back that information. So when the application is sending this data, it will do some headers, like it will package this message. You have the data and then you have some header on top of that. You will need to know who it is coming from, who it is destined to, all that stuff. So that information is like the label. Just think about the address label on your message mail post thing, right? You have something kept inside that, and then outside you have a label. Okay, this has to go somewhere, and then it cannot go that. So then there are so many things. I mean, I don't. Maybe I shouldn't go too deep into that. But basically, what happens now is you need to establish a connection between these two servers, and so it will use something called a protocol called use TCP, is transfer control protocol. So this is a transfer. It is controlling the transfer between these two. That's the protocol which allows the transfers between these two, the messages. So it will make the packets, it will cut it short into manageable sizes, and it will put some headers on top of that, and some up, and it will take the whole thing, even including the header and the data, and then puts its own header, and then it will also packetize that to multiple manageable sizes. And then there is another layer, and there are these have different meanings, but for the networking side, they all make sense. Ultimately, you will have this. This is the IP layer, like this. At this level, you are only looking at this. So at this level, it is only looking at my IP address is this. I want to go to this IP address. It doesn't care what it is sent or what is going or anything like that. It has so many IP packets, and it is just sending it out. And but at the layer, at this level, the layer 2, it is looking at the MAC addresses. Like every one below IP address, every machine has a MAC address, so it is addressing at that level, and it is sending into the network interface card of the machines. So that's where it happens. And eventually, the network interface card is a physical thing, and it can receive all these pulses. And at that layer, it will start and stop, and it will have control signals to when to start, when to stop, all kinds of things. At the end of the day, it is sending all these pulses, and once the pulses reach here, this layer will assemble and then create this frame, and then bunch of those frames will be assembled, and at this layer it will take the IP. Ultimately, the application will get this message. That's how it happens. Actually, it is a very complicated system, but it all these things happens within the flip of a second when you hit your return, and then you get back all these things. That's kind of the beauty of all this stuff, right? So it's a really amazing thing if you think about it. All right. So any questions so far?
Nope, so
Is
far
this
so good.
is this a little bit too overwhelming, or is it right
No,
right
no,
on?
no. This is quite, yeah. No, it's
Oh,
not.
okay.
As a non-IT person, I can say it's quite easy to follow.
Okay, sounds great. All right, let me just go to the next slide here. So now I will talk about the business application. So there are different architectures when you build an application. I will just think about a 3-tier architecture. But even initially, when we didn't have this kind of maturity at our application build out process, eventually we used to initially we actually had everything written in a single box. Like you hit one box and you have the whole logic written in a big monolithic chunk of code, right? That was really difficult to manage, and if anything has to change, the whole thing has to be replaced. It's just think about, like, you have a car and then you have to change the tire of the car, and then the tire is connected to your engine, and then the engine has to be replaced. So the whole car has to be replaced. That is not modular. Like, you need to have a design that is much more like a Lego pieces and then modular. And we evolved all these there is much more evolved architectures. I'm just trying to show you something like a 3-tier architecture here. So basically what it means is, like, we are just talking about, if you go back here, I'm talking about this piece here, and the customer is sitting at this. Let's forget about all these things happening in between. You are reaching here and you are getting back something from there. So that's what happens here. So you are a user, and then you have this data center hosted application. And the data center hosted application, you have a presentation layer, right? So that is where you are defining how the whole thing has to be presented to you. So we are actually splitting the logic into three modules. Like the presentation is independent of how the business is doing. Like it's almost like you're calling somebody on the phone, and the way he talks doesn't mean anything about how he is doing it. He's writing it in the ledger or whatever, like he's looking at somewhere else, doesn't matter. Like it should not be dependent. So we have real good interfaces we define between presentation layer and the business layer. So the business layer is where the computations happen, right? The presentation layer is where you have the charts, you have all those things which are coming off of the computation layer happens, right? So we actually modularize. So if you have to change the look and feel of the application, you just replace the presentation layer, and those things will remain the same. That's how we modularize the application, right? And then the data layer is where the data is residing. Like it could be in a, like, just think about an Excel sheet. Like you have all the tables, and then you are having a computation like on the tables, and which is like, and then ultimately you have a chart which like take the computation and show it to you. So these kind of things, right? So the data layer is this could be a complex process, right? And I'm not showing the back end part of that. There could be so many things coming into the data layer, like such as let's say if you are having credit card, it is not solely depending on your own system. There could be transactions coming from the merchant. There could be visa type things. So many data flow in and out of this. So those are all captured here. Ultimately, let's consider that everything is packaged and you have a single box where the data is residing. And that data's format should not depending on how you process it. And if something changes on the data's the way data is organized, maybe there is a small change in the business layer, but ultimately we should not be combining all these things together. That's the beauty of this three-tier architecture. And there are some other architectures like message oriented and then microservices and stuff like that, but that's too much for the to the IT guys. But anyway, so this is how, and now you are seeing this kind of thing hosted in the data center. So this is the application build out process. When I am working for a company and they are asking me, okay, I need to have a website doing such and such things, and this actually interacts with the backend, this process, and it gets data from here. So we actually do a design process, and then we build all these things, and we build this stuff in the data center, like hosted in my own data center, right? And that's the old way of doing things. And now let's see how this will change when you go into a cloud. So this is how a data center will look like. Again, it will have it's a big building, and again it is going to be multiple buildings in they will have an airspace between one building and the other, because something happens the whole building, you will have redundancy on the other side. There is a lot of redundancies they build out. And so basically you have generators, batteries, all kinds of stuff, racks and servers, and these are all physical servers. And then we, as I mentioned before, we'll create virtual machines on top of all that. And this is kind of a typical data center, like if you cut it out open. And this is Microsoft's data center in Quincy, Washington. And this is like one building, the second building. This is a bunch of servers. So there may be four buildings here, because, and there will be redundancies. Like if this whole thing is powered down, and it still will be able to support you guys, because it will have it will have redundancy built between all these things, right? So it will, and again, when we build applications, we will make sure that not everything is put in the same box or something like that, or in the same place. So those are the considerations around application resiliency and things like that. But if you go inside, you will see something like here. Like this is all, if you go inside one of the things, like you will have so many servers and connections and wirings and all kinds of things that happens. And that's where all these things are served from. So hopefully this makes sense. Right? Any questions? Okay. Yeah. So now let's talk about on-premises versus cloud computing. So on-premises is like generator, like you are making your own electricity. And if you're talking about cloud computing, it is almost like buying electricity from the grid. So nobody nowadays creates their own electricity. So what is the problem with doing this? Because it is a lot of capital investment. First of all, like you have to pay for all these things. You keep it. You have to do the maintenance. You have to do all that stuff. And then when there is a capacity addition, you are building a new room or new something. Then you need to make sure that this can have enough horsepower to do all that stuff, or we just need to buy another one. All these things are problematic, right? So that is how the old way of doing things. That is how the data center people used to own their own data centers, and now they are actually going to the cloud providers who will provide the data center for these people, right? That is the cloud business. uh, so it's a electrical the real comparison here is make your own electricity versus the power generation and distribution from the modern way of doing things. Like the so the how do these distribution companies make money? They actually optimize their environment. They actually um, they will shut down generators. They will bring up generators as demand is happening. When the demand goes up, there will be multiple generators coming into play, and when the demand goes down, some of those things will shut down. The grid will be optimized and all kinds of things. That's called the economies of scale. Like, based on the scale, you make money, and the volume business as well. So that's how the cloud computing guys make business, and then instead of doing it on premises like this. So now this actually brings up the characteristics of cloud. So when you are providing a service like that, so now we are talking about a service-oriented business, where you are providing compute power and horsepower for other people. And so how do we make it? What does it mean by providing a cloud computing service? It means that you are providing on-demand self-service. Suppose I am a customer for a cloud and I wanted a bunch of horsepower and computers. I will be able to push a button and get a bunch of resources for me to do my job. So that's an automated process. I don't have to call somebody, and I don't have to wait in line or anything like that. It's a demand self-driven, on-demand self-service driven process. And the second thing is a broad network access. The cloud computing should provide support for connecting your customers, your data center, your applications, and the cloud. So it should allow you all the network access available or required for your business. So if you are putting in the cloud and you cannot access, your customers cannot get there, then that is make no sense, right? So it should provide you all these access points and access where they can do your business. The third thing is called the resource pooling. Resource pooling is again so cloud is a multi-tenant environment, which means more people. There are so many people living there, right? So Capital One may be doing business with. I know that Capital One does a lot of business with Amazon. So they are using their cloud service. They're actually having their business in Amazon, and then there are other companies that buying resources from Amazon. So basically, the cloud people actually optimize all these things by sharing resources with isolation, right? Sharing resources is actually problematic when there is security concerns and all kinds of things. So basically, sharing resources in a very controlled way, all right? I can have a single machine, but multiple people can use it, a chunk of that and a chunk of the other piece of that, without having them seeing each other. So that's how cloud will optimize these kind of things. So it's a multi-tenant environment, and it will pool the resources for different people and share and all that stuff. That's how the cloud computing makes a lot of money. And then the last thing, a couple of things, is measured services. Now that I am providing a measured service, I have to provide you a bill. And it is almost like selling electricity. I need to know how much you used, and then how much is the exact amount that I need to pay me for using my resources. So that's why we need to have in on-premises, you don't really care. It is all yours, and you just you keep using it. And in the cloud business, you have to really capture keep the exact cost for everybody. And then the last one, at least, the rapid elasticity, because when more and more people come in, I cannot say that, oh, I don't have any capacity now. I cannot serve you, right? So we need to just keep adding all these things at the back. All right. So I will rush through these things. There are three types of cloud. One is called public cloud. That is actually the Amazon, Microsoft type things, where you buy cloud services from a public vendor. Private cloud is again you build your own cloud in on premises, which is like the difference between the old system and the private cloud is private cloud actually and kind of adopts some of those cloud principles. Cloud principles such that you can have rapid elasticity, self-automated provisioning, all sorts of things like that's kind of the private cloud. You don't go into you still do your own generator, but you will have made it such a way that it is resembling the public cloud. All those characteristics are brought in, and then you provide services within your own company. And the last one is called hybrid cloud, and most people are doing this these days, like because they may have a legacy cloud system, or sorry, legacy on-premises environment, and they may be moving some things into cloud, some of them still be remaining on premises. So they will have a hybrid architecture where some systems are served off of on premises, and they may have an exit strategy sometimes, like they will have sort of criteria when to move stuff, what to move, depending on certain things. And most of the guys are like using hybrid cloud these days because it is actually how the way the whole thing has evolved. But eventually there are some companies called cloud born companies. Some of the startup companies sometimes do everything cloud, they don't even have a non-premises footprint. So that's kind of the new generation stuff. But if you are like a company that has been around for some time, usually you will have a hybrid cloud. So I think, Aramal, you asked about physical machine and virtual machine, right? So this is the difference actually. So a physical machine, you have the hardware at the bottom, you have the CPU, memory, the cards, the disk and everything, and on top of that you have an operating system, which is Windows or Mac or Linux or whatever it is, and then you run your application inside that operating system. The operating system is actually your master brain, which actually does a lot of things. It will schedule the applications, it will do resource sharing, it will swap out, it will sometimes the memory is full and then you need more memory, it will take out some application and put something else. All sorts of things happen, and it will actually allow the application to access the system level resources such as memory, and all those things are actually encapsulated and then provided as the operating system provides you that. The application is more like a higher level, it will only talk at its own language, and then operating system takes that and then executes all these things. It will schedule these things. If you have multiple applications, let's say if you have multiple windows open, and when you click on one of the windows, that comes into the forefront and other things are still running, but there will be a single CPU only sometimes. Like at a point of time, you can only run something. So the operating system is doing all these kind of things at the back end. So it is kind of your orchestrator, pretty much doing all that stuff. So that's the physical machine. But if you are looking at a virtual machine, you have a infrastructure which is similar to a physical machine. And top of that, you run something called a hypervisor. A hypervisor is actually providing you a layer. That's another program which runs on top of the infrastructure. Instead of the operating system, you run the hypervisor. The hypervisor actually has the provision to give you virtual machines within the same hardware. The hypervisor is the one that actually you can interact with the hypervisor and tell that, okay, I need one virtual machine, VM1, let's say Windows machine. I need another machine, VM2, which is a Linux machine. So the hypervisor will act as that proxy or the broker in between the infrastructure and the virtual machine, and then it will provide you the virtual machines on top of that. So basically within the, so that's how most of the physical the data centers right now are using virtual machines. So underneath the cover, they have all these physical hardware, they'll rack up all these things and then put hypervisors on that. And then when you are actually asking for a server, it will create the the request reaches the hypervisor and it creates a server for you, and you will only have access to that server and it gives back to you. So there is no physical box sitting there. It is actually something called a virtual machine, which means that it is really like, actually this is like an application. If you look at it, it is similar to this application, but this application is mimicking like a machine. So it's a this application simulating a machine. So that is actually the virtual machine. So hope that makes sense. Any questions on that? All right.
This looks
So
it's clear.
cool. So now let's look at the types of cloud services. So when you are buying cloud services, there are different things you can buy. One is called a software as a service, or SaaS. So and this can be done for personal usage or as well as for companies usage. So typical SaaS offering means that you are not really bothered about the application or anything, but you only just get an account. Somebody is hosting the application for you, and then you are just, your account provisioning is the only thing that you do. Basically, you just go and then, for example, is you are having a Dropbox account. Somebody is running Dropbox, or like somebody is running Office 365 or something like that, and you create an account on that, and then you get the software as a service, and you don't really care about that. And that whoever is providing that service has the ownership of taking care of everything. Like if there are 1,000 users more today, and then they have out of capacity, taking care of all that stuff at the back end is their problem, right? It's not your problem. You're just using it. And that's the, at the top level, you are having the SaaS offerings, and end users interact with that, which you and me and even companies actually, for example, companies try to do, uh, you know, Office 365, which is like they can provide cloud-based file storage and cloud-based you know, um, emails and all kinds of things. So that's a kind of a SaaS architecture. The second thing is called a platform as a service. So when you buy services from a cloud, you can actually buy a platform service. So which means that the shell or the where you are putting your application is prefabricated for you by the vendor, right? So you can actually buy a server and then build your own stuff. That is called infrastructure service. But you don't want a server. You wanted something like you are running a web application, and you need a web host. And there are a bunch of things. And if you are a programmer and you know, developer and all that, you know, you need you just don't care about the machine or anything. You just need an environment where you can put your code and then that will run. So that's called a platform. And then the benefit of that is like you don't really care about patching up the server, making sure the server is secure, all sorts of things. Like you get the platform, and then the responsibility is split now. You are only responsible for deploying your application, the security of your application. The security around that is, and all the capacity management, scaling up and down, all sorts of things relies on the vendor of the cloud. So that's the platform service. And the last one, but not least, is the infrastructure service, where you buy the solid pieces of bricks, and then you just build all that stuff. And in this scenario, you are responsible for making sure that everything in the server, if somebody hits us, like somebody puts a virus in the server, that's your problem, right? Because you're only getting the server. But in the platform as service, you are encapsulated from all that stuff, right? That's the three layers of cloud services you can buy from a cloud vendor. So there is this, let's say if you're, you know, just an example, I can tell you this. If you are thinking your app is your dinner, like you're having a nice dinner, something like chapati or something like that for today. So IaaS means you go into the grocery store, buy everything one by one, like, you know, all that stuff, you cook it up, and then you cut it, and then you know how to do it, you do all that stuff. But in the PaaS service, let's say you can have a prepackaged stuff, and then you get the sliced and diced stuff in a packet, and there is a recipe. Okay, you take that and then just do it. And the SaaS product, you just go to a restaurant and then eat it. You don't care. You just pay and then get that out. And you basically nothing is your problem, right? Somebody else is building all these things. And these are the three different options that you can have. So hopefully that makes it clear. So now this is the, so this is pretty much from the Azure side. So this is how usually a data center will look like. The underneath everything, you have a bunch of physical hosts. These are all the racks and the servers that you have. That is a data center infrastructure. Microsoft Azure has 60 plus regions, and we host all these things. We have 60 regions, and I think more than 60 now. And then every region has multiple data centers for redundancy purposes. So on top of the data center, we have the virtual layer of infrastructure. I just mentioned around physical infrastructure and the virtual infrastructure, right? On top of that, you have the compute infrastructure, which is the machines and the containers and all that stuff, and the storage infrastructure. You need disks and files and all sorts of things. Disks will be attached with the computers. So all these things are virtual, so they are not attached directly into that. So you will have a virtual machine, virtual disk, which will attach to a virtual machine. So all these things are layered on top of the physical architecture. And then you have a software-defined networking. So I am on cloud, and then I have a bunch of systems, and I want to interconnect those things. I have a network layer that is defined only for me. So that is a virtual networking layer that I have. So on top of the physical infrastructure, we have the infrastructure as a services. This is the basic thing you can buy. On top of that, you have platform services. There are a lot of tools, and again, they're all built on top of the infrastructure services. When you buy this level, Microsoft will have the infrastructure built for that, and then you get this service on top of it, right? That's how the platform services work. And that's how the layering happens. And software service, I did not mention here. It is basically just somebody is running it, and then you get that account. And there are a bunch of management tools on either side of this, which are all common services that actually allows you to monitor, to make sure that your cost management, your monitoring, your CPU utilization, your all sorts of graphs and dashboards around your infrastructure is done through this security management. And hybrid cloud also gets you a lot of tools that allows you to connect from on-prem to Azure or like your cloud. And so those are the connectivity options and stuff like that. So basically those are management tools. And then you have the platform services and the infrastructure services. Underneath you have the data center infrastructure. So that's how the big picture looks like. And now this is how we connect all these things. And so right now, if you look at it, like you have so many regions in US, there are so much bunch of regions. These are all the Azure provided data centers. And customers can build their stuff anywhere in all these data centers. Like let's say I'm a customer sitting in India. I can host my applications in this data center. Or if I am in Australia, I can do all these places. And then all these are interconnected through dark fiber, which is Microsoft owned fiber. And then there is interconnections between all these. There is terrestrial and subsea cables, which are actually connecting all these things. And then, if you look at this, look at these metrics, this is massive actually. It's 2 million miles of data center fiber, and then 60 plus Azure regions, 100 plus data centers. Each region may have multiple each region has multiple data centers. So it will double the size of the 60 here. And all these things are interconnected. So this is how the whole infrastructure looks like for cloud business. And customers are actually coming and taking infrastructure services or PaaS services or whatever they want from all these places. And you can build your application. And the beauty of this is that you can also build your global application. You can build applications that are actually hosted in multiple regions, and you can load balance your application. Like let's say, depending on, I'm a big multi-region global business, and I want my customers to be directed to the location they are very close to for reducing the latency and turnaround time. So we will, so they will all hit the same URL. Like, they will, let's say google.com or capital.com or microsoft.com, but underneath the cover, they will be located. This resolution happens such that we will have load balancing strategies and all kinds of things, which will let them go into a server that is sitting very close to them, and they will get the optimal experience. That's how you see how these things flashing in a second. And it is not really going all the way across the sea and finding somewhere else. These are all like balanced in the deployment model. So I actually talked about the North Pacific, and we have lots of Cape. I don't want to go too far into that, but anyway, I think I mentioned the core infrastructure. We have compute, storage, networking, and the management infrastructure in the cloud business. So now let's say the network big picture. So I am hosting an application in cloud, and here is my main office, and here is my branch office, and here are my customers. Traditionally, the whole thing would have resided in one of my branches or in my offices, but now I am sitting in my office in any of these buildings, and I am managing my infrastructure, which is in the cloud. So I have connectivities created between my office and cloud. There are two different ways you can connect. It's called for direct connectivity, we call something called express route, which is much faster, or you can create something called a VPN tunnel. This is similar to how you work from home and connect between your office and you. Similar to that, there's a site-to-site VPN. What you do is a point-to-site VPN where you are a single person is connecting to office, but there is a big pipe connected through internet, and this is again something encrypted. And actually, there is no tunnel in internet. Everything goes through internet, but then because of the encryption, the encryption can happen at different levels, right? So when you hit a URL, let's say you are saying HTTPS, it is an application level encryption, and you are encrypting your data and then sending it on the wire. But in this scenario, what you are encrypting is you are encrypting even the addresses and the IP level. So that's called IP security encryption, and that's how you create a tunnel. There is no tunnel, like it's almost like the traffic is going across the internet, but then you don't know where this traffic is coming from and where it is going, because you mask all the address information and everything, and you put address labels on top of that and then put it out. And then that's how the encryption happens between these two locations. That's the IPsec encryption. And then this is pretty much you create private lines, not going through internet. And so what happens here is, if you are familiar with your on premises is like your home. So whenever you are having an office building or a home, you have computers in your home. And what you have inside your home is called local area network, and what you have outside is called wide area network. So it's called WAN and the LAN. So the wide area network has very unique addresses. My endpoint in the internet is unique, and nobody else will have, because internet will have to want to know where to go. That inside my home, I will have private IP addresses, which is common between me and you or somebody else in the office as well. So that's called the private IPs and public IPs. And this is like, inside your home, you have different locations, like you can have a bathroom or a bedroom or whatever it is. It is common for everybody. But my home address is the same. And how to reach that is a unique place. Inside that, I don't care, like, nobody else knows about it. So similar to that, so basically this cloud is a public internet place, is placed in the internet, and it is a publicly addressable space. But inside that, you need to create a private area for these connections. That's called the virtual network. So basically, you are extending your on-premises local area network and then tunneling through this, and then you are creating a area within Azure or a public place. That is where you are. And again, all these servers sitting inside this private network is almost like sitting close to your on-premises machines. Like I have a machine sitting in my home, and then I have a machine sitting in a virtual machine sitting in Azure or in any other cloud. It will have an address range similar to what I have. So it is almost like my cousin or somebody sitting somewhere else, even though they are sitting in a data center like miles away. So this is how we create a private addressing space within Azure or any other cloud. So the cloud is a multi-tenant environment. You can imagine this as an apartment complex where everybody has a complex, a room or like a building, whatever they rent, and then that has to be isolated, and it's your private addressing space, and that's how it happens within Azure. And then the customers are actually hitting the public endpoint. They cannot see all these things. They will hit the company's URL, and then you will get routed into that. And from here, you do all the management, and then there may be some, I also mentioned about hybrid connectivity, right? There may be some databases sitting in on-premises, and this application may be connecting and pulling some data off of your on premises as well. So this could be a computation environment that could be hybrid as well. It need not be entirely contained within the in the cloud. It could be a hybrid environment where it can pull data from other places as well. So that's the network big picture for cloud. Any questions on this? I think this is a pretty elaborate slide, I think.
No.
All right. So yeah, now let's talk about computing options. So I talked about networking. So in the cloud infrastructure, we can have network, compute, and storage. So we talked about networking, how the networking connection happens, and now we can talk about compute. So I can build any number of machines in cloud and use for my usage. So there are different, just like you buy stuff from the grocery, there are a menu item here. Like, you can have several types of machines you can buy. You can have an entry level machine. You can have a burstable machine. Burstable means like it may not be always like heavy, but then at sometimes you may need more horsepower. So you will the costing structure of that is optimized for that kind of a pattern. So that's called burstable. So for example, like, if you are, and I can also talk about an example of Black Friday, for example. Like, in the during Black Friday, if you are like hosting all these on premises, like your Black Friday timeframe is coming, and then you are worried that your website is going to be hit by thousands and thousands of users, and then you will have to beef up your environment just for that purpose. So then you will buy much more servers, connect all this thing, load balance them, and make them highly available, all kinds of things. But if you are using cloud, then you can actually scale your infrastructure at that time and then scale back at the point of time. So it's basically you're paying more at that time and not owning all that stuff. So similar thing, like you can actually do burstable servers, which actually even at the server level, you can burst and then come back, and then you pay for an optimized price for that. There are general purpose servers. There are compute intensive servers. There may be some servers which need high compute power, like very process oriented stuff, and GPU enabled servers. For example, if you are doing some genomics or like graphical stuff, then you need GPU machines. And then you are also high performance computing. And then there are memory optimized servers. If you are more interested in a database type application where there's a bunch of data, not much computing, then you need to make the quick presentation. And at that time, memory optimized may be a good. So we need to decide based on the type of application, what type of machines you need. And there's a palette of stuff that you can actually pick and choose from. And there are also special purpose machines built for certain applications as well. There are also storage options, and I won't go too far into these things, but then there is a disk storage, which is actually attached with the machines, like virtual machines. You can actually, the storage is also like, when you think about a cloud data center, you will have, they will buy and add storage into racks, like, and then the storage will be then virtualized, and then you will get a piece of the storage for each purpose. Like that's how the storage management happens. And then so basically most people will be familiar with the disk storage. So you will have to add when you build a virtual machine, you will add disk storage into that, and then that is actually carved out of the storage backend infrastructure. So I think I talked about platform as a service. So again, that is again a repetition here. So I would also touch upon something called DevOps. So DevOps is a factory-like process, right? In the beginning, when we were building applications and deploying applications, developers will sit and write applications in their own local environment. And then they will take that and then put it in a production environment where it is like sent it to the customer. Like there may be multiple environments, like developer environment, there is a test environment, and then finally a production environment. And all these machines are like in the past, these environments are also much more physical in the beginning. And so we know where we are going to put. But now the environment itself is like virtual, right? So we can bring your environment just like that. And then you can kill your environment and then delete all the environment as well. So the environment itself is a code now. So that's called infrastructure as code. So basically what we do is it's a factory like environment now. So when I am coding something and I'm trying to build some stuff, and I actually write the code for building my environment, and then I deploy the code into that, test all that stuff, and then I tear down the environment and just get out of it, and I don't use it anymore. And then the whole thing goes, there's a pipeline like that. So basically you commit the code into a repository or like a place where you can put all the code together, and the code gets built and then tested, and then all these things happen. There is a pipeline built, and then basically that people like Facebook and all that, like basically they type they just keep adding their features just like that. Like somebody pushes in the code, it will automatically build, it will automatically tested, and then and it will get into the production the same day. And then initially when we were like building all these things, we used to plan all these things. It is not possible for like financial applications and things like that, which needs much more compliance and all that. But for social media applications, what the heck, there is a small bug or something like that. So such things can be done very easily like that. But for even for financial and monetary specific applications, you can still do a lot of automation like this. So there is, everything is code now. So software is everything now. So you just need to know, you might have heard about something called a full stack developer now. It's called, initially developers were application developers who were actually building a specific application. They really don't know about the backend infrastructure. They give to somebody for deployment. The IT department will have people who are called system integrators, who are actually taking this code and then putting in the system and then doing all kinds of things. So there is development and operations. So those two things merged, and we call it DevOps. And developers actually build these things. They play with that, and then that's why they call the full stack developers. They also know the backend infrastructure, how to code the infrastructure and things like that. So that's all about, so that is how fast things are moving. Like if I remember like 10-15 years back, I can, when I have a business problem, I will wait for 3 months or 4 months to get a server. And then all sorts of, we call it a waterfall model. Like, we just do one at a time, then do the development, design and all that, do the testing and all that, then finally goes to production. It's called a waterfall thing. But now it's called an agile methodology, where everything is doing in parallel. And then there is no way we can wait for 2 days or like 3 months now. Because the business problem itself will become obsolete after like a couple of weeks. Because if you don't do now, somebody else will do it, or like things will not happen, and stuff has to be moved very fast. That's why these things happen. The cloud is important, and then DevOps is also important for those things. I think I covered the basics benefits of cloud computing. First of all, the cost. Cloud eliminates the capital expenditure. So basically your capex will become opex, which is operational expenditures. So eventually you will get rid of your capital, and then you will become more like service oriented and operational expenses. The global scale. So let's say if you are a company who wanted to do business in Mexico, if you don't have a data center in Mexico, you cannot build an application and deploy there, right? So, and then you may have to partner with some data center providers, and then that's how it used to happen in the beginning. Now with the cloud is everywhere, right? You can have a data center in Mexico or wherever it is, and then you can within a day you can actually have your application run in a different place without even knowing. So that's called the global scale of things. The performance is the cloud is always optimized, and then at the back end, cloud providers build high speed networks, and they upgrade and they actually do the business of keeping up the architecture and the background infrastructure up to speed with the latest technologies. So you don't really invest in time and energy in doing all that stuff. So the performance, right? And now finally, security. Cloud providers actually comply with the whole bunch of security policies and all that stuff, which, and again, when you are running your own thing, you will need to make sure that you will have the right talent and skill set to do all the security problems. And sometimes there is a risk running stuff without knowing what's going on. So because cloud is a service, there will be security experts in the cloud business itself. Like they will take care of the platform security and stuff like that much more than you will do. And again, I think there are other things like speed, then productivity, reliability. I mean, I think you got the point. So I leave it up to you guys. And I think that's all I had. Hopefully this made some sense at a very, very high level. It's not the details, but I just wanted to talk about the high level big picture of a cloud computing. Yep. Any questions so far? Yeah, James, somebody wants to ask a question. All right, Khalil, I think I don't see any more questions. So maybe that's a good place to stop, I think, right? Okay, I think Khalil has stopped. So maybe I will just close the meeting. Thanks everyone for joining. And I think Khalil will have the presentation recording. So thanks again. Have a good weekend.
Thank you.
All right.
Thank you, sir.